Hello everyone, I'm Craig. Welcome to Get Smarter and Make Stuff. Well, today we're going to talk some more about the electronic lead screw project. If you want to know more about that, I'll put a link up in the corner. Where is it? It's over here. For the other videos in that series, explain a little bit about what I'm doing. If you have followed along, you'll know that I ran into some problems last time. I think I've overcome all but one of those. So today we're going to get to look at where I've gotten to and actually see the thing make a few chips, and I'll talk about what's left to do. Alright, we're over here at the lathe, and as usual it's a major challenge to fit all the cameras in, but I think I can show you where I've gotten to and you'll be able to see pretty well. So first of all, I got the enclosure mounted up here above the lathe. I think I'm pretty happy with that. I might need to do a little bit of work to route the cables just a little bit better, but in general I'm pretty happy with that. Got the motor, that's out of view right now. Got the motor down here mounted up in line with the lead screw. And that's just basically how I showed you last time. I didn't wind up doing anything special as far as attaching it to that hex end cap. Seems to be holding up okay. I did think about the fact that if I wanted to do something other than the set screw nonsense that I was complaining about last time, that I could go ahead and just grind a flat on the threads there, chase it with a die maybe just to clean them up a little bit, and then that should give a place for the set screw to grab onto. But so far seems fine. No slipping as far as I can tell, at least in that part of the mechanism, but more about that in a second. I'll show a picture of the inside of I'll insert a picture of the inside of the enclosure here in a minute. It's a little hard to get to right now, but I'll go back and put that in post. It's pretty much as you saw it last time, but I can just reach the switch pretty conveniently, and you can see that the lead screw control interface comes up here on the lathe, and I put in the CA there, and the version number was 14 CA, just to indicate that I've made some minor modifications to the firmware, just as a reminder to myself that I'm slightly different from James's implementation. I've got a piece of steel chucked up here in the lathe, and we can go ahead and see how nice it is to have this electronic lead screw. So what I'll do is go ahead and just turn this on without engaging the tool yet, and let me see if that shows up on video. Yep, you should be able to see, just barely crank this out of the way. You should be able to see the lead screw. Yeah, I think you can see the lead screw turning here, and as I turn up the speed, might be a little bit hard to see. It turns, and right now we're running at 5 thousandths per revolution. So let me go ahead and get the tool positioned here and just take a cut. And I've tried this out already, and believe me, it is very, very nice to be able to control that relationship between the lead screw and the spindle and the lead screw. Let's go ahead and get this fired up. And I'll just brush a little bit of where to put my brush. Just get a little, this is a scrap piece of steel I've got going here. This will be a bit of an interrupted cut, so might be a little bit bumpy. Let's go ahead and crank that up to about 700 RPM. And I want to point one thing out. When you look here at the difference between the RPM readout on the lathe itself and on the lead screw readout, they're very close. We'll come back to that in a minute, why that's important. Anyway, let's go ahead and make a cut. Touch off. All right, and then go ahead and engage the lead screw. And this first pass will just be just to get it going. Just do a little bit of it, don't need the whole thing. Okay, and let me actually turn on my DRO so I can get back to where I was. All right, and let's go ahead and take a, let's try 10 thousandths. 7, 8, 9, 10. All right, let's go ahead and give that a try. You can hear it's interrupted. All right, and let's take a look at that. Okay, so to my eye and finger, that's a little bit rough. So what's nice here is I could probably do a little bit better with a slower feed. Let's say this is a finishing pass. So all I had to do there was go ahead and just bump that button down a couple times. And now when I run this thing, Let's go ahead and take another 10,000ths pass, go up to 20. Now when I take another pass, I don't know if you can tell or not that it's going slower, but it's certainly, I can tell. And that's a carbide tool, so I'm probably running this way too slow. I just want to show you the fact that it's so easy to dial that feed rate up and down. Alright, let's see how we did there. Yeah, and see, I can tell. I don't know if you can see it or not, but I can tell that that is much nicer. Again, probably would have to run the lathe a lot faster for that to really do a good job. But just this being able to move up and down with a touch of a button, that's really what I was after with this project, and that is just super nice. Okay, so there's two things that I might want to do here. One is feeding, like I just showed you, but the other one is threading. So we have this thread mode button, and we can put it to feed. And I'm not going to show that to you because there is a problem. That is the last remaining problem. Basically, what happens is when I tried to thread, what I discovered is instead of tracking in exactly the same track every time, the lathe is getting off somehow. It's almost like the stepper is losing steps, but it's not actually the stepper losing steps. What's going on is happening down here at the headstock end of the lathe. And to show you that, I'm just going to have to reposition the cameras real quick, so give me a minute. Okay, I think you should be able to see on one of these two cameras at least. So the problem, I believe, lies down here with the gears that connect the headstock to the rotary encoder right here. The rotary encoder is how the electronic lead screw senses the position of the spindle. I've got the banjo, is it banjo? Whatever this thing is called, swung away from being engaged with the headstock, just so you can see it better. But ordinarily this gear would be contacting the gear that is connected to the spindle, so as the spindle turns, this would turn. Now one of the slightly weird things that's going on here is that the gear here is 60 teeth and the gear on the spindle is 40 teeth. So we've got a 3-to-2 relationship. So I've made pulleys that are also 3-to-2, so that by the time we get back to the encoder, the relationship is 1-to-1 with the spindle. So we should see one rotation of the spindle results in one rotation of the rotary encoder. Now I printed these pulleys, and the reason is that I couldn't find pulleys that are small enough to fit in this extremely confined space that had no flange on them. And so I thought I could 3D print some, but as we'll see, there was a bit of a problem with that. So let me go ahead and make a mark here so I can show you what the issue is. And I'll just make a V here, and then a corresponding V down here. So what we're going to see is, as I rotate this, the bottom one should rotate 3 times for every 2 times the top one rotates. So in fact, if we turn it, yeah, that looks about right. You can see that one's upside. That's 1 rotation to the top. This one's done 1.5, so that seems good. And if we get to the top, it lines up. So that all seems good. The problem is that when this is under load, and I might even be able to get it to happen right now if I just spin it by hand a bunch. All right, so let's see what happened. Yeah, you can see what happened there, right? They're no longer exactly lined up. This one is a little bit ahead of this one. And I think what's happening is that the teeth on the pulleys that I printed are not quite lined up. And so what's happening is, instead of the belt meshing nicely, every once in a while what it's doing is one of the teeth will kind of ride on top of the pulley, and you'll wind up skipping over. Or possibly under. It's not really sure, not really clear, but it's either going to be that there's 2 belt teeth in a single pulley slot, or there's 2 pulley slots for a single belt tooth. And that's probably because these 3D printed, and I want to show you here, I've actually made a ton of these trying to overcome this problem. Anyway, you can just see I've made a whole bunch of these trying different numbers of teeth and different sizes just to see if I could overcome the problem. And it is a lot better. It's a lot better. But you can see even still, if I just spin this by hand, I can get it to mess up. So it's just not good enough for threading. You can imagine what would happen if you're threading and you're going along and you just sort of decided to miss a few steps. Well, now you're no longer tracking in the same groove, and the thread is completely ruined. So what I've done is ordered some aluminum pulleys, manufactured ones, so they should be right. Some GT2. This is a GT2 belt, so those should be correct. And when they come, I'll need to machine them down to be able to fit in here, take the hub off, maybe drill a hole for a set screw so it can go on the coder. Maybe something else. I'm not really sure exactly. I'll have to wait and see when I get them how that works. But then I should be able to replace these, and hopefully at that point everything will be working. But the good news is, even with it like this, I'm still able to use it to turn to a diameter, like if I'm not threading. And frankly, I don't do that much threading. I have a full set of taps and dies, and those work perfectly well for most situations. I actually do have a situation where I need to do a what is it, 3/4 6 TPI thread, and I don't have a tap for that. I actually do have a tap for that, but it really only works with wood, and I'd like to make an aluminum part to fix a broken broom. Actually, maybe I'll show that when I do that. It's a pretty simple turning project. So I actually would like to use this feature, but in the meantime, the lathe is perfectly usable. It doesn't really matter if I'm just turning to a diameter, if the relationship between the spindle and the lead screw is exactly 0.003 per rev, or if it's, you know, more like 2.7. Doesn't really matter. Close enough is good enough there. So the lathe is totally usable right now. Gonna call this project a success. But I do want to fix this because I really would like to use it for threading. This is a really nice feature of this setup. Just be able to, you know, turn that turn your TPI up and down with a push of a button. Anyway, that's where I've gotten to. Pretty happy, actually, that I was able to figure this out. I spent a really long time looking at this thing and turning these and going, how is it possible, if this thing has 60 teeth and this thing has 40 teeth, that when I turn it, it's coming up, you know, uneven. It just didn't seem like that could be happening. But once I realized that my tooth profiles are probably not exactly correct, then that kind of answered the question. Can't actually see it. I can't observe that directly, other than through the fact that the thing gets off. It must be that somehow. I will note, by the way, that I did attempt both to produce my own tooth profile. I went into Fusion 360 because I couldn't find a Fusion 360 GT2 pulley generator, and so I actually kind of whipped one up on my own. Thought I got it right. That was definitely not right. After that, went out to Thingiverse and used a library I found there. Thought that would work. Also did not work. I tried tweaking all of the tunable parameters, making the pulley teeth slightly bigger, slightly smaller. None of it did any good. It is closer than it was, but it's still clearly not good enough for threading, and I really would like to get it there. So, like I say, should have more to say about this as I get the parts in that I need, and I'm going to machine them down and try them out. I'm sure I'll do a video on that as well, and then this thing should be good to go. So I'm pretty psyched. Like I said, it's totally usable right now. Anyway, hope that was at least moderately interesting and perhaps entertaining. As certainly it was been a big lesson for me on, you know, how important it is, how sensitive gears are to the tooth profile. Really good lesson for me to take forward as I do more things. Kind of my first foray, one of my first forays, I should say, into this kind of thing. So if you also found it interesting or helpful or useful, go ahead and click that like button if you like, and consider subscribing to the channel. That does help. When people subscribe, I know, hey, this is the kind of video people enjoy. I'll make more of those because it's fun to put things out that people like. But if not, that's cool. Appreciate you watching in any event. And thanks a lot for watching. I will catch you next time on Get Smarter and Make Stuff.